Okay, good morning once again. Happy New Year to all.
Good morning, ma'am.
Happy New Year.
Happy New Year. Happy New Year, Mikias. Where is Ergibe?
Good morning, ma'am.
Okay, now we will start the class, online class again. Class would not take any class. So today I will be taking this hour. I will take and my hour 1:30 also. So these 2 hours I will be handling. What about your physical classes? Because circular has come that PG first year physical classes will start from today. What is your you will be able to attend the class? Did you inform to your class teacher about that? Is rep for this class?
Ravi Kumar, sir.
Now, who is the class representative? The class representative is not selected. Okay. Mikias is telling he is not able to. Is my voice clear to everyone?
Breaking.
It's breaking. Others, please. Others. Please respond. Shweta.
Breaking, ma'am. Voice is breaking.
Still now also.
Now it's okay, ma'am.
Okay. Here I have a good network. It is showing. I don't know what is the issue. So today, shall we start the class where we have stopped in the last previous week? Is the slide visible to you?
Yes, ma'am.
Different types of loading. So what we have discussed was the gravity loads, we have gravity load, dead load, gravity load, live load, the impact load. Next, we discuss the construction loads, then the earthquake loads, here is the where we have stopped last class. Okay, and we started discussing the code IS 1893 2016. Okay, I hope every. Do you have the code book with you? Do you have the IS 1893 code book with you? Is a soft copy?
Ma'am, yes, ma'am, yes, ma'am. Posted it.
Others?
Ma'am.
Calculate to other groups, other students, Jagan?
Ma'am?
Did you circulate the
Yes, ma'am, I forwarded in the group, ma'am.
code to other students?
Ma'am, we have. Ma'am.
Which group? In you have it. Okay, okay. In the MTech group, you have circulated? You have shared?
Ma'am, I shared to all the students, ma'am, and I posted in Teams also, ma'am. Class materials folder.
So if it is there with you, you can keep it with you. Otherwise, you can see, I will project that, but I have the 2002 only. Again, you can put it in the group. But the group is there, no? You can put it there.
Yes, ma'am, yes.
Oh. So today I will share the IS 1893 2002. There is not except some soil conditions. Okay, so that we are not going to study in detail now for this particular course. This particular we are more concentrating on the calculation of earthquake, how to calculate the earthquake load. Okay, so here so when we do the earthquake, when we calculate the earthquake forces, one is called a static analysis and other one is called a dynamic analysis. Okay, so static analysis is done for where the importance factor around 1. That means normal buildings where there is not much importance is there, like power plant or fire station. So such other than that, your residential building, commercial buildings, normal buildings, you can go for a static analysis. Okay. Power stations or any other very important structures, monumental structures, bridges. So such very important structures, we can go for dynamic analysis. The procedure for finding earthquake load or the earthquake forces, the first step is to find out the seismic coefficient. Last class I have explained seismic coefficient. Okay, I'll just now quickly go through the IS and I'll tell you the procedure for doing the static analysis. Okay, so the next step and the third step is you have to find out the base shear. That means the total force that is coming at the base of the structure, that is called base shear. If it is a multi, I hope my voice is clear now. Is it clear? Is my voice clear now?
Yes, ma'am.
Yes,
Okay. Okay, so that's how to calculate, and some of you must have already done. Those who have not learned can listen now and you can do this. Okay, okay. And the last step is you have to distribute the along each floor of the building. You can distribute the total base shear, that is the force that is coming at the base of the structure, can be distributed to each force. Okay, that means I'll just explain you. Suppose you have a building with the 1, 2, 3 story. So here base shear is the total force that is coming at the base. Okay, at the base of the structure, what is the total force that is coming? That is called base shear. That is, this base shear can be distributed to each floor. It can be distributed to each floor. This is the second floor, third floor. So how it is distributed? This VB can be distributed as Q1, Q3, like that. It can be distributed to each floor. Okay, so that is what we have to calculate using a static analysis. The seismic coefficient, the first step, A, on the equation that is given in the IS code, AH is equal to into I into SA by G, that is one term, SA by G divided, discussed in the last class, where result is called the zone factor, I is importance factor, R is called the response reduction factor, and S acceleration coefficient. Okay, it is the coefficient. So once you calculate the value of AH from the building information, okay, next the next step is to calculate the seismic weight. Seismic weight is nothing but the total weight of the floor wise, the total weight of the building, including the dead load and. So your IS code, when we calculate the seismic weight for the roof, I'll show you it in the IS code. When you calculate the seismic weight of the roof, that means if you have a building like this, okay, this portion is the roof portion. So when you calculate the weight of the roof, you have to consider only the full dead load and live load need not be considered when you calculate the seismic weight. I told you the reason once. When there is an earthquake happening, you cannot expect, we cannot expect any live load on the roof because every full evacuation will be happening there. So when you calculate the design forces, the weight of the building, the dead load is sufficient. Okay, so the full dead load on the roof is sufficient for the calculation of seismic weight of the roof. But when we calculate for the floor, each second floor, first floor, ground floor, etc., for every floor, when we, it is the full dead load plus an appropriate percentage of live load, an appropriate. IS code has a specific percentage of live load. If the live load is less than 3 kilonewton per meter square, 3 kilonewton per meter square, then you need to consider only 25% of the live load. Okay, you need to consider only 25% of the live. If it is more than 3 kilonewton per meter square, you have to consider 50% of the live load when you calculate the seismic weight. It is given in IS code. I will show you that. Okay. W3, the third floor, W2 for the second floor, W1 for the first floor. So your W is nothing but plus W2 plus W3, the total sigma of W, that is called the seismic weight. Okay. So once you calculate the seismic weight, then the third base shear is calculated. VB is equal to AH into W, where AH is the acceleration coefficient and W is the seismic weight. Okay, and compute the using this expression. Wait 1 minute. This base shear can be distributed based upon the height of the building and the weight of Wi hi square divided by sigma of Wi hi square. That means based upon the height of the building from the ground floor and the weight of the. Okay. So this is what it is given in the IS code. I'll just go through the IS code and I'll tell you where it is. Can you see the IS code now? Can you see the IS code?
Yes, ma'am.
Please respond to my question.
Visible, ma'am.
Otherwise, how do I know? I'm not able to see your face. So I should know that what I am teaching is just coming to you. Are you able to understand? Speaking, you tell me, you stop me in between. Just like that, listen like that. Okay. So can you see this now? 7.3.
Yes, ma'am.
Yes, ma'am.
So here it is given 7.3.1. Can anybody read this 7.3.1? Please, one of you can read.
For various loading classes as specified in IS 875, Part 2, the earthquake force shall be calculated for the full dead load plus the percentage of imposed load. Second point also.
Given in. That's what I was telling. Next step. Next.
For calculating the design seismic forces of the structure, the imposed load on roof need not be considered.
The imposed load on the roof need not be considered. So for calculating the design, the imposed load is nothing but the live load. The live load on the roof need not be considered. Okay.
The percentage of imposed loads given in 7.3 and 7.3.2.
That you leave it. You just read now 7.4.2.
Seismic weight of building. The seismic weight of the whole building is the sum of the seismic weights of all the floors.
Okay. So seismic weight W is the. Okay. So seismic weight, how to calculate it? That is what we were discussing now. Okay. Now it is given in table 8. How to calculate table? I'll go to table. What is the table 8 says? Read the table 8.
Percentage of imposed load to the considered in seismic weight calculation.
So it is given up to and including 3. If the imposed up to and including 3 kilonewton per meter square, what is the percentage of imposed load to be considered?
25.
How much percentage?
25%.
25%. If the live load is above 3, then how much? It is 50%. This is what I was explaining you in the slide. If the live load is less than or equal to 3 kilonewton per meter square, then 25% of the live load has to be added along with the dead load. If it is more, the live load has to be added along with the dead load. Okay. So this is how we calculate the seismic weight of the building. Now, when we come back to 7.5.3. Somebody else can read. Shweta can read. Shweta.
Design seismic base shear.
Mm.
The total design lateral force or a design seismic base shear VB along any principal direction shall be determined by the following expression. VB is equal to AHW.
What is that?
AH is design horizontal acceleration.
Okay. Okay. VB is VB is equal to AH into, where AH is the horizontal acceleration spectrum coefficient and W is the seismic weight of the building that we have discussed previously. Okay. So this is how you calculate A. But can you tell me the expression? AH is equal to? What is the expression for AH?
ZI into
SA
by G
SA by G
by
divided
2R.
By
2R.
R. Okay. So in that there is a term SA by G. Okay. So the here last class I explained you how to calculate your SA by G. Here there are 3 types of soil. How to calculate the SA? Okay. So here there is a term called time period T. So this time period according between 0 and 0.1, then it is 1 plus 15T for a hard soil. Similarly, you have 3 different types of SA by G for different types of soil it is given. How to calculate this T? I'll come back to Can you see this here? 7.6.2.
Yes, ma'am.
Please read it.
The approximate fundamental natural period of vibration TA is in seconds of all the other building, including moment resisting frame building with brick
or other buildings.
Including moment resisting frame building with brick infill panels may be estimated by the empirical expression. TA is equal
by
to
the empirical expression.
TA is equal to 0.09 by dV.
There is a small, please all of you please correct it and write it in your notebook. It is 0.09 h, small h, 0.09 h by root of d. Please make a note of it in your notebook. You can write it. Buildings with the brick infill. You can see a term here, brick infill. Okay. All moment resisting frame with the brick infill. The time period. Please make a correction. Okay. Where h is the height of the building in meters and d is the base diameter level in meter along the considered direction of the lateral. That means, okay, so I'll explain you. When I do the problem, I'll explain you. Please make a note of it. Please write this. Okay, 0.09 h by root d. This is for buildings with the brick infill. So here, can you read? And 1. .6.1.
The approximate fundamental natural period of vibration TA in seconds of a moment resisting frame building without brick infill panel may be estimated by the
Listen.
empirical.
This clause is for without brick in that.
TA is equal to 0.075 h power 0.75 for RC buildings and 0.085 h power 0.75 for steel frame buildings.
where h is the height of the building in ways you can calculate the t value time period. One is for structures without infill and one is structures with infill. Most of the is with infill only because we are not in any with infill. Okay, so you will be using this expression 0.09 h by root of d. So once then according to the t value, you can calculate your SA by G. Then you can calculate the t values. So if the t value is between 0 and according to the type of soil, you can calculate the SA by G. Okay. I hope you are able to understand what I am telling. Now, so this is what once that is calculated will be calculated, then the base shear VB is equal to AH into W. So once you calculate the base shear, next we can distribute that base shear along the height of the floor. Can anybody read 7.7.1? Who was reading previous? Please read. Kritika.
Ma'am, Kritika can't see the screen, ma'am. So can I?
Yeah,
I'll read, ma'am. I'll read, ma'am. Vertical distribution of base shear to different floor levels. The design base shear VB computed in 7.5.3 shall be distributed along the height of the building as per the following expressions. QI equal to VB into WI HI square divided by WJ HJ square.
Okay, so that means problem. We will do the problem now, where QI is the design lateral force at the floor. WI is the seismic weight of the eighth floor. HI is the height of the floor I measured from is the height that is measured from the base, and N is the number of stories in the building. Okay, so this is how the static analysis we do. Okay. Now I'll come back to the PT. So these are the 4 steps you have to do. It is for a static analysis. Okay. Now shall we do one problem now? Okay, Mikias, are you able to understand what we were discussing?
Yes, ma'am. I'm following you.
Oh, okay. Okay. Now we will. And those who have already know, you can proceed with that. Others follow me. Okay. This dynamic analysis. So, Mikias, can you read this question?
Okay, ma'am. A residential building located in Mumbai has 5 floors with a total height of 16.3 meter. The ground floor is 3.5 meter and the remaining floor are with a height of 3.2 meter each. The soil is medium. The plan dimension is 20 meter by 15 meter. Calculate the base shear and design lateral for each floor. If the building building is converted into a hospital building, comment on the base shear. Dead load, floor equals 12 kilonewton per meter square. Roof is equals 10 kilonewton per meter square. Live load, floor equals 4 kilonewton per meter square. Roof equals 1.5 per meter square.
Okay. So here, a residential building, sorry. A residential building has 1 minute. One second, okay. A residential building located in Mumbai has 5 floors, 16.3 meters. So what we have to do now here, you just draw a small diagram. Okay, with this information you can draw a diagram. A residential building has floors, 5 floors. Okay, so 1, 2, 3, 4 and 5. Okay, floor, third floor, fourth floor and fifth floor. Okay, it has a total height of 16.3. So the total height of the building is the ground floor is 3.5 meter. So the height of this bit here, this is 3.5, and each floor it is 3.2. Height of each floor is 3.2. Okay. So then the soil condition is medium soil. The plan meter. So the building has a plan dimension 20 meter. If I consider this is my x direction, and this is my y direction. So this is 20 meter by 15 meter. Okay. So the 20 meter by 15 and height 16.3 meter. Calculate the base shear and the design lateral force at each floor. Okay, it's a residential building. So now what is the first step as per our previous static and seismic coefficient? So how to calculate the seismic coefficient AH? What's the formula for AH? Please tell me. AH is equal to Z into, you also please do it, okay? Plus do I SA by G divided 2 R. Okay. Now, what is Z known as? What is Z?
Zone factor.
So zone factor depends on what? Where the building is located. Now where the building is located here, it is in Mumbai, isn't it? The building is located in, so Mumbai falls in which zone? So your IS code Your IS code at the end, you have an annexure. Okay. There's an annexure for zone factor for some important towns. Okay. So here some
Zone 3, Amma.
So where is Mumbai lies here? You can see where is Mumbai. You can see here Mumbai. So Mumbai is in zone 3. Zone 3, what is the importance factor? Sorry, zone factor. How much?
0.16.
Okay, so here you can refer your. So Mikias, this is what we are discussing is the Indian standard. Okay, so when you are studying, I told you can one day explain portal provisions, how to calculate all these things. One day, I hope you will explain that. I think this Friday, you can prepare that. Okay. So now what we are discussing is the Indian region is divided into 4 zones. Zone 2, 3, 4 and so now according to the question, the Mumbai is in zone. So the so Z is how much? Z is coming as 0.16. What is I known? What is I known as? What is I? Those who have already studied the subject can answer no immediately. What is I? Any idea?
Importance factor.
Importance factor. You see, IS code. You can see table 6. What is importance factor? There are only 2 factors. One is 1 and another one is 1.5. So hospital, schools, monumental structures, emergency building, telephone exchange, telephone station, radio station, railway station, fire station, community halls like cinema, assembly halls, subway station. Such buildings, the importance factor is 1.5. All other buildings, it is 1. What was our question? A residential building. What is the importance factor now?
1, ma.
1. So the importance factor is 1 for the building that is a residential. Okay. So importance factor is 1. Now, before going to the SI by G, first let us calculate R. What is R known as? Anybody remember what is R?
Response reduction factor.
Response, you can see response reduction for the building systems. Okay. So there are different building systems that is given here. First one is ordinary rainfall. If nothing is mentioned in your question, then almost all residential buildings, all commercial buildings are of OMRF, that is ordinary. Otherwise, it will be mentioned in your question. The building is a special moment resisting frame or a concentric brace with or a shear wall. If the then R value can be taken as for an ordinary moment resisting frame. The value of R is 3. Is it clear? Okay. So here R value is 3 for, you can mention, it is for an ordinary resisting frame. Okay, this is from table 7. Now, next we will. Okay, so how to calculate the SA by G?
Ma'am, R value how much, ma'am?
3. Did you see the table here? This is the.
Yes, ma'am.
The first one. The R value is 3. Now, we have to calculate your SA by G. Okay. Now we have to calculate SA. So for calculating SA by G, you need to find out what is the value of T. Isn't it? T. What is the formula for T? That from the code we have discussed. T is equal to H divided by square root of. Okay. This is with the brick infill. Naturally, a residential building will be with a brick infill. Okay. Equal to 0.09 H by root of D. What is the H? Is the height of the building. What is the height of the building in your problem? 16.3 meters, isn't it? So H is equal to 16.3. And what about the D? D is given as the base dimension. What is your plan dimension? I have mentioned that plan dimension was 20 meter.
20 by 15.
15. Okay. So now there are if you see the definition of D, you see the definition of D. 1 minute. So you can see here, it is the base dimension of the building at the plinth level in meters along the lateral force, along the considered direction of the lateral force. So that means the considered direction of lateral force means, so I told you this is my X direction, Y direction. Okay. This is my X direction, Y direction. So if I assume, if my earthquake force is coming in the X direction, will be, because we don't know in which direction the earthquake forces are coming. Okay. So if I assume that my earthquake forces are coming in the X direction, then my D value. If the earthquake forces are in the Y direction, then my D value is 15. So I have to find out the value of T, the time period, in both the directions. Okay. So very clearly, earthquake forces are in which direction it is coming. So you need to calculate in both the directions. So here the time period has to be calculated in X direction as well as in the Y direction. So first we will calculate it for. Please tell me the value. Please calculate and tell me in the X direction what is the value. 0.09 into 16.3 divided by
0.32.
how much?
0.32.
0.32. Similarly, in the Y direction, you tell me. Similarly, the value of T in the Y direction also.
0.37.
0.37. Okay. So you got the value of T as 0.32 in one direction and 0.37 in the one other direction. Now let us calculate the value of SA by G. Now calculate the SA by G from the code. What is the type of soil given for you? It is a medium soil, isn't it? The soil is medium. Okay. So for medium soil, is the SA by G. same soil. That's for this. What is time period is how much? 0.32, isn't it? In which case out of these three?
Second case.
What is the value of SA by G? Second case. So how much is SA by G?
2.50.
2.5.
How much?
2.50.
2.50. In both the values of T, isn't it? In the second case also T is, it is 0.32. Both the values lies in between 0.1 and so your SA by G is 2.5 in both the cases. Okay. So we can write SA by G as 2.5. So because it is same for both the cases, you don't have to write. Okay. Otherwise, you have to write down SA by G in the X direction, SA by G in the Y. So now you got the value of Z, you got the value of I, and you got the value of SA by G. Now can you calculate what is the value of AH? Calculate the value of AH and tell me. The formula for AH I have written here.
0.06.
AH is coming as how much?
0.066.
0.06.
Is it correct for everybody? Is it right?
Yes, ma'am. You have the same answer.
Yes, ma'am.
Okay, so AH is coming as 0.06. So this is one value you have calculated. Now let's calculate what is the next. The next step is seismic weight. Seismic weight. So how do you calculate the seismic weight? So how do we calculate the seismic weight? How many floors? We have 5 floors, isn't it? 1, 2, 3, 4, and W4, W3, W2, and W1. So the sum of W1, W2, W3, W4, and W5 will give you the seismic weight W. Okay. So now how do you calculate this each one? The code says, what does the code says? For the roof, if I take the roof, which is the roof here, which weight it is that? Isn't it? This is your roof. So for the roof, what is the code says how to calculate? It is the full dead load plus 0 live load. Okay, there is no live load. Okay, 0% of the live load. That means there is no. For the roof, you don't have to consider the. Now tell me what will be your dead load. What is the question? Question says that how much?
Ten marks.
For the roof, you don't have to. How much?
10 kilonewton per meter square.
Dead load is 10 kilonewton square. The dead load on the roof is 10 kilonewton per meter square. What is the floor area? What is the floor area?
300 meters square.
How much? 20 into 15. So the floor area is 300 meters square. So the dead load is 10 kilonewton per meter square. W5 will be 20 into 15, that is the floor area, multiplied by 10 kilo. So how much? It is it correct?
Yes, ma'am.
Okay. So this is the floor area. So this much of floor area. So total load on the roof is 3000 kilonewton. Now we have to calculate W4, W3, W2 and W1. So for all the floor, what is the dead load? How much is the dead load for the floor?
12.
12 kilonewton per meter square. Okay. And how much is the live load?
4.
4. Okay. So if the live load is 4 kilonewton per meter square, how much percentage we have to consider? How much I told you. Do you remember? If the live load is more than 3 kilonewton per meter square, you have to consider 50% of the live load. So how do you calculate here? Your W4 W3 all together, isn't it? W4, W3, W2, W1 all will be same, isn't it? This is how much full dead load 50% of the live load. 50% of the live load. Full dead load plus 50% of the live load. What was the dead load? Area is 300, isn't it? Floor area is 300. Dead load was how much? 12 kilonewton. So 12 plus what is the 50% of live load is how much?
2.
Was how much? The live load was 4 kilonewton per meter square. It is 2. Is it correct? Is this clear? Is this step understood to you? Dead plus live load is 300 into 2. And understood or not?
Bracket correct, ma'am.
Which one?
12 will multiply by 300, no, ma'am, before itself.
How much was the dead load for the floor? 12 kilonewton per meter square each floor.
Yes, ma'am.
So for each floor 12 kilonewton per meter square. So for an area of 300, that is the dead load on the floor. Dead load on the floor will be 300 into 12, correct?
Yes, ma'am. 3,600.
Live load. Live load, you have to consider only 50% of the live load.
2.
So 50% means 300 into.
Okay, ma'am.
4 by 2. 4 was the 4 by 2. So that means 300 into 2. So when you add these two, I have taken 300 outside, 300 into.
Ma'am. Ma'am, we didn't add live load at the roof, ma'am.
Live load at the in the roof, there is a clause. Here I have say full dead load plus no live load.
Okay, ma'am.
Okay. So this is one clause you have to be. Live load is given in the problem, but you don't have to take. You don't have to take it for the roof. Only dead load. That's what we have taken here. For the roof, you have only dead load. Dead load for the roof is given as 10 kilonewton per meter square.
Oh, 4,200.
4,000 kilonewton. Okay. So you have the W1, W2, W3, W4 and W5, you got it. So what is the total seismic? Total seismic weight W will W1 plus W2 plus W3 plus W4 plus how much? That means 4,200 into 4 plus 3,000.
19,800.
19,000?
800.
Is it 19,800? Check once again. 4,200 into 4. Okay, correct. 19,000. How much? 19,800.
9,800, ma'am.
800.
Correct. Okay. 19,800 is the W value. So now you got the value of W also. Okay. So you got the value of W. AH was how much? 0.06, isn't it?
Yes, ma'am.
Okay. So AH and W you got it. So the third step, your base. How much? What's the formula? VB is equal to AH into W. This is the base shear. How much you tell me?
Ma'am, 1188.
118 kilonewton. So the base shear, that means the total force that is coming at the base of this building is 1,188 kilonewton. Is it clear? Is this understood up to this? Now we'll continue this problem at 1:30 hour. Okay. Is this clear, all of you? Any doubt?
Clear, ma'am.
Okay. What happened to Kritika is she's not able to see the video.
Ma'am, power cut, ma'am. Network issue.
Oh, power. Okay, okay. Okay, then we will meet again at 1:30. We'll continue this problem and finish it.
Okay. Thank you, ma'am.
Okay, what happened to Sharath Kumar? Sharath?
Ma'am, no proper response, ma'am.
No problem. Any idea or others? Why she is not attending? Is she attending all other classes?
Ragaba, it's a network problem, I think, ma'am.
What happened?
It's network problem issue, I think.
Network issue. Oh.
Yeah.
Okay. Okay, then